Okay, we have exercise 10.2, question 2. The first question is to prove that ABF is congruent to triangle CDE. Okay, ABF and CDE. Okay, first off, right off the bat, I know that AF is equals to CE. And this is because they are opposite sides of a square. It's given that this AFC is a square. Then I will also know that angle AFB is equals to angle CED. Pay attention to the order of vertices. Is equals to 90 degrees because this is a square. This is 90. This is 90. This will also be 90. And finally, okay, I know that BF is equals to DE. And this is given. Hence, I can conclude that triangle ABF is congruent to triangle CDE. And the reason for this is side, angle, side congruency. So quite easily done, angle ABF and CDE. Now, part 2. Part 2 would like us to prove that ABCD is a parallelogram. Okay, parallelogram, right, in order for me to prove that it is a parallelogram, what I need to do, okay, I write it here first, is to prove, okay, number 1, that the opposite sides are equal. So AB equals to CD. And number 2, okay, 1, okay, and 2, one other thing that I would like to prove is that AB is parallel to CD. So if I can do this, my mission is complete. I have proven that ABCD is a parallelogram. These two sides equal, they are parallel, done. Okay, parallelogram. So let's get started. So first I say triangle ABF is congruent to CDE. This is from part 1. Okay, and then therefore AB is equals to CD. Alright, opposite sides corresponding sides of congruent triangles must be equal. So AB equals to CD. So I've done the first part here. AB equals to CD. Next one that we need is to prove that AB is parallel to CD. So in order for me to prove that parallel, okay, I need to prove that triangle ABF, okay, plus angle BCD, okay, sorry, ABC. I need to prove that angle ABC, which is ABF, plus angle BCD is equals to 180 degrees. Okay, so this is what I must prove. Why I need to prove this, okay, is because if these two angles add up to 180 degrees, it simply means that this entire thing, right, these two sides are corresponding angles. It will prove that AB is parallel to CD, which is my mission number 2. Okay, so now what I do here first is this. Alright, let me name this angle as X. So if this is X by congruent triangles, this angle will also be X. Can? Okay, now, so I say let angle ABF equals to angle CDE equals to X. Alright, now what happens here is this. So therefore, angle DCE is equals to 180, this angle now DCE, okay, is equals to 180 degrees minus angle 90 degrees minus X. Okay, 180 degrees minus 90 minus X will give me DCE. So angle DCE is equals to 90 minus X, like this. So I know that this angle is equals to 90 minus X. Can? Okay, now I will now let angle ABC plus angle BCD is equals to ABC. Just now we have defined it already. ABC is equals to X. Okay, BCD. Okay, BCD will be 90 degrees. Why 90 degrees? Because this is 90 degrees, which is BCE. Okay, plus 90 minus X. So therefore, ABC plus BCD, X plus 180 degrees minus X. X minus X is no X. So angle ABC plus BCD is equals to 180 degrees. So since I proved that these two angles, they add up 180 degrees, I can conclude that AB is parallel to CD. Correspond by the reason of interior angles add up to 180 degrees. And therefore, my mission number 2 is complete, where I prove that AB is parallel to CD. So I will write the statement: since AB equals to CD and AB is parallel to CD, comma, ABCD is a parallelogram. And I am done with question 2. Okay, for question 3, using the property of parallel sides in a parallelogram, prove that triangle ABD is congruent to CDB. Okay, let's get started. Okay, first, right, in triangle ABD and CDB, I know that angle ABD is equals to angle CDB, because this is because of alternate angles, and this is possible because AB is parallel to CD. AB, CD are parallel, so basically I'm saying that this angle and this angle, okay, by the Z, okay, alternate angles, they are equal. Then also I will know that BD is equal to DB, so BD is common. Alright, and one more angle that I can prove is angle ADB is equals to angle CBD. Same reason as above, is because of alternate angles, and this case is because AD is parallel to BC. Then notice I got one angle, two angle at one side. That is sufficient proof for congruency. So I say that triangle ABD is congruent to triangle CDB by angle side similarity, congruency. And I am done with question 3 part 1. Now we move on to question 3 part 2. Hence prove that the parallelogram ABCD has two pairs of parallel sides. Okay, so prove that the parallelogram has two pairs of equal sides. So equal side, equal side. Okay, so this one's simple enough. Okay, from 1 I will have triangle ABD is congruent to triangle CDB. Okay, this one is from part 1. Okay, then now I know that AB is equals to CD. This is, okay, the corresponding sides of congruent triangle. Similarly, I will also prove that AD is equals to CB. Also same reason, corresponding side of congruent triangles. Hence I have, as answered the question, proven that the parallelogram has two pairs of equal sides, and it is proven. And we are done with question 3. Stay tuned for the next video where we'll move on to question 7 and question 12.